Last question. Question 7. Give an example of a continuous function f such that the series converges but the improper integral does not. This looks very similar to the integral test, right? So for integral test, suppose you have f that is continuous, decreasing, okay, and the limit is equal to 0. Then this if and only if this. But here we want the series converges but not the improper integral. So we need to violate either this or maybe this, right? So we just need to give a function that is continuous, but it is not a decreasing function, right? So maybe, for example, we can have fx is equal to what? The function that is not decreasing means it is something that is going up and down, up and down. So maybe we can make use of sine function. Okay, sine function. But let's say if I use sine x, then I'm not sure whether the sum of the sine n converges or not, right? In fact, yeah, it shouldn't converge, right? Yes, so we need to manipulate this, right? We want, because we want the sum of fn converges, but the integral from 1 to infinity of fx dx diverges. So as long as it is in the form of sine of something, the integral from 1 to infinity will diverge, right? The problem now is I want to construct the sum of fn so that it converges. So why don't we introduce a constant pi here? Okay, because we know that sine of k pi, sorry, sine of n pi let me use blue color. Sine of n pi will always be equal to 0. So the sum of n pi, okay, is just the sum of zeros, which is 0. Hence it converges, but then the integral of sine nx from 1 to infinity diverges. Okay, so let's write this properly. Okay, let fx be sine of x pi. Okay, then the sum n from 1 to infinity of f of n is just the sum n from 1 to infinity of sine of n pi, and this is just the sum of zeros, and this is equal to 0. But the integral, limit t tends to infinity, the integral from 1 to t of sine, right, of fx dx, this is limit t tends to infinity of integral from 1 to t of sine of pi x dx, and this is equal to limit t tends to infinity of 1 over pi times minus cosine of pi x 1t. This is equal to limit t tends to infinity of 1 over pi minus cosine pi t plus cosine of pi, but this limit does not exist, right? So yes, indeed, this is one of the example. Okay, so we can use this as the example. Done.